Hey Art, here's the way I'm thinking about it. Here are your three equations. And what I was thinking of doing is saying, well, let's just make a guess that x equals 0. Then I would get these three, and I could solve any two for y and z. Turns out solving the bottom two is easy because you can see that the y's are going to go away. So at x equals 0, if I plug in x equals 0, I can actually do some manipulations, and I can get what z needs to be, -5, and then plug back into just one of these bottom two, and I can get what y needs to be, -9. Quick check that it actually satisfies, because I actually did the middle equation to get from z to y. I'll double check in the bottom equation, make sure I didn't do anything stupid. Yep, it works. And then what I do is I now have an x, a y, and a z guess. X was 0, y is -9, z is -5. That makes you consistent with the bottom two. You check it into the first, and of course you don't get the right answer. You get 52, but it should have been 1. So there's a discrepancy between my left hand, my guesses, and what it should have been. So I'm going to call the discrepancy 52 minus 1 is 51. Now I'll guess x equals 1. So I just go back in and I do the same thing. I'm just going to solve these bottom two equations. I have a 1 here. It just changes around. Turns out z doesn't change at all. But it makes an adjustment to y, and I have a new x, z, y solution. Plug it into the top one, and I get a slightly worse discrepancy. It used to be 51, now it's 51.5. So the answer must be x is negative. So what I did is I put it into a spreadsheet. So I said, okay, put my guess across the top, and it's actually just entered into here. And you can see that I think I got to the right answer. So I just plug in a 0 here. It turns out z is always going to be -5, which is really, really weird, because basically what happens is when I add and subtract, and when I add the bottom two equations, when I add these two equations, the x's go away and the y's go away. So it turns out, using from these bottom two equations, z is always going to be -5. So that's just a fluke, but whatever. So anyways, I just stretched that all the way across. Now y, it turns out that it's always just going to be 2 minus x plus 4 times z divided by 2. That's just solving that the second equation. So I just plug that in as a formula, and I stretch that formula across. Then I have an x, a z, and a y, so I can plug in the left-hand side, and I just plug in the top equation, minus x minus 3y minus 5z. And I stretch that across. And the right-hand side is always just 1, so I subtract the 2. So my discrepancy was 51, then it went to 51.5. So I went the wrong way. So let's try -1. Aha. So it turns out I could guess that, oh, it must be, I need about 100. So I tried -100. I still had a discrepancy. I tried -102, and look, I get the same answer. So I'm pretty sure this is the solution to those three equations. And I only had to make guesses about one of the variables.